Good morning. Thank you all for joining us. We'll be kicking off in about 2 or 3 minutes, and I shall be with you shortly. So I do beg your pardon. I think I've got a different clock on my laptop and on my phone, and I realised we're actually past the start time. I beg your pardon. I've been running to an entirely different clock, and that's why I've been sitting here on mute. Sorry to keep you waiting. I shall move on. So these sessions will be recorded. Questions are absolutely welcome as we go. We have time allocated for Q&A at the end, but you're very welcome to ask questions as we go. And then finally, we have at the bottom a link for the slides, which will be dropped into your chat very shortly. So you can go and follow the slides as we go. I'm going to do a very quick introduction to myself, as much as anything, so that you can kind of think about my prejudices, what I've brought to the baggage I've brought with me when I come in as a trainer. So I started at ST Microelectronics in the late 90s, while I joined a toolset team. And in that particular era, the real-time operating system was part of the toolset. So I was always been an operating system engineer, but as part of a toolset team. And then as the set-top box industry pivoted from custom RTOSes to GNU Linux in the early noughties, I kind of followed along with it. And during the time since, I've worked pretty much everywhere you can in a set-top box software organization, with the exception of security. I joined Lenara in 2014. So I've had lots of kernel experience in that kind of ST era, but no upstreaming. I joined Lenara in 2014, initially in the kernel working group, where I worked on trying to improve debugger technologies in the kernel, and then became tech lead for the support and solutions engineering team, which is where I am now, where I lead things like training and support. I've got a couple of small maintainer roles, KGDB and Backlight. And whatever I do, that kind of background that I have in tools and operating systems, whether it is as a trainer or an upstream maintainer, it does tend to shine through. That's where I've come from, and that's what I do most. So we're here today to talk about upstreaming. And we're going to go sort of hard and fast and sort of talk about what upstreaming is to set the scene. It's called upstreaming because the normal view is that in classic computing systems, code flowed downstream from the development project through kind of delivery and to its users. And when users and intermediate developers give code back to the project, that code can be viewed as going upstream. This is probably the key insight, which is why I've changed the background color. I've got here two different definitions of upstreaming. The first is that it's a process of moving code from downstream vendor trees into the top level Linux repository maintained by Linus Torvalds, which we call the mainline. That's a very functional description of upstreaming. It is what you are doing, but it gives you absolutely no clue about how to upstream anything. What we have in the bottom right is an alternative definition of upstreaming. It's a process of technical and social influencing to persuade a kernel maintainer that it's better to include your changes than it is to ignore your changes. And that is a very how description. That is what you're actually doing when you upstream. So one is goal-oriented, the other is much more focused on what you're doing. And the key thing here is that upstreaming is not just technical, it is a social influencing process, and that your goal when you are upstreaming is to persuade a maintainer to apply your changes. And that will sort of suffuse the rest of the presentation today. finally, this kind of intro section about what is upstreaming. Mechanically, upstreaming for the vast majority of kernel engineers is the act of posting patches to a mailing list, which is the key mechanism by which you persuade maintainers to accept your code. And it provides maintainers with all the information they need to accept your code. So this is just an example set that we picked out from a great deal of choice. So in this case, this is what's called the covering letter. It's at the front, and it summarizes, in this case, the changes that have been made to the patch set as it works through. In this case, there's not a long description in the covering letter because the title here, display and GPU clock enablement, is sufficient to describe everything that's happening. And let me get to the next slide. The second part of the mails that you send out are the main patches. These are literally specifying the changes you seek to get applied. They get sent out on the mailing list as part of this set. These do have clear descriptions of what the patch does. And that is the very kind of essence of upstreaming. And then we see conversations. So this is a standard email conversation. You'll notice it's all inline posted, where we have this very simple single comment, dual license, which is a reminder that the license information that has been applied to this particular file wasn't acceptable upstream. There are specific rules for the dual licensing of device tree bindings, so that they can be used by the BSDs as well as by Linux. And you can then see finally the reply from Robert, who's one of our engineers, is simply ACK. So it's not very wordy conversational exchange. It's a very simple, quiet exchange. Yeah, dual license ACK, and that ACK means that the next patch series that comes out, when version 5 of this patch set comes out, Robert will have agreed to change the licensing here. So that's upstreaming. So too is this. And this is just an example of quite a sophisticated and difficult piece of upstreaming to enable a relatively complex new x86 technology called AMX. And because it was quite difficult to manage things like how the context saves should be implemented most efficiently and effectively, I don't remember all the technical details, but if you are interested, there's the article at the bottom. But because it was contentious, because it was difficult, there was a fringe meeting that took place off list, verbal discussion with Thomas and these other people minuted. And this is the summary of the agreement that was made between these 5 engineers. And it was shared publicly so that others could contribute. It basically provides, this is a proposal of how we think it should be done, to solicit agreement to try and reduce the work. That is every bit as much upstreaming as sharing patches, because it is part of that social influencing process to set a direction that others will agree with over time. So that's just some hints about where we're heading towards. Obviously, we will introduce the tools and some of the philosophy behind all the things you've just seen, but just to put it front and center, that is what upstreaming is in the kind of most succinct way. And why would you do it? So reducing costs definitely factors into this. The ways you can reduce the costs are things like you are sharing the support effort. Particularly if you're a SOC vendor and you have good upstream support, then other ecosystem players, which I'll put in quotes as the community, invest in understanding how your upstream code works. You get an ecosystem of contracting companies that some of your customers can use to help them. You also gain access to a wider ecosystem, in particular distributions. Depending on which markets you're selling into, then you can open up additional niche markets, you can open up larger markets by allowing distros to support you. Whether that means bringing in the really big guns, you know, kind of Red Hat and CoreOS type products to produce operating systems for edge devices and so on, or whether that is adding particular custom features from smaller players in the market, you gain that access to a wider ecosystem. I think I've hinted at contracting companies as part of this shared support effort. And finally, you get a very well understood process for your customers to actually contribute features and bug fixes. Upstreaming is a relatively well understood process. There are plenty of training courses on how to do it effectively, which both you and your customers can take part in. And it allows customers to get that really clear path. Even when you are willing to accept code from your customers, when you manage everything in-house, the customers just don't know how to deliver it to you. You might want to do it to increase the quality and generality of your code. Upstream does have industry-leading quality standards. And once code has been upstreamed, maintainers do a lot of the kind of mechanical maintenance aspects. So updating to match latest APIs is expected to be done by the proponent of whatever API is being changed. You may well still have to contribute to the testing of the code that you have upstreamed, but keeping it aligned with the kernel in good condition is now a shared role. The final why upstream is because you are required to by either influential customers or middleware providers. So it is becoming the case that some of the largest and most influential customers' middlewares are in a position to start expecting SOC vendors to upstream drivers, which they require partly because of their own reduced costs, and so they can contribute to the shared effort, the shared support effort, and so that they can own part of their own future without being dependent on you to provide the next version, the next version, the next version. And finally, this little note at the comment bottom here, upstreaming may well require a slightly different, longer term approach compared to product trees. So we'll look into that as we go through. Let's check if I've got more interesting. Last thing in this introduction is to introduce the concept of working in the upstream, because this is another reason you might choose to have an upstreaming program. So this course is about upstreaming, the process of taking that code from downstream vendor kernels to the mainline kernel. But working in the upstream is what can happen next. Working in the upstream is when the upstream Linux kernel, the mainline, becomes your primary focus and is where features land first. So you do upstream first, then you backport. And your development tracks that kind of bleeding edge of Linux development. And the reason that can be interesting is that working in the upstream allows companies to participate in leading Linux kernel development rather than following it. Particularly if you're introducing novel features, extensions to particular pieces of peripherals. You can do vendor additions, which will then go through multiple evolutions over time, and then somebody will introduce it to the Linux kernel, possibly differently to the way you've done it, and then you end up with that kind of disjoint system where the upstream kernel requires one set of features or one set of software, and your legacy platform is built differently. That's good for time to market reasons. Going on your own can get you to market quicker, but it is painful for your customers to have two different versions of the same driver running through. So one thing to put in your minds is that for embedded platforms, working in the upstream only becomes possible when sufficient upstreaming has already been undertaken that you can meaningfully work in the upstream, that the kernel is sufficiently feature enabled for your platform that working in the upstream becomes feasible. So almost all the tools and techniques and habits to work in the upstream are essentially similar to the tools, techniques and habits you use for upstreaming as a goal in itself. So there's a natural progression from upstreaming to working in the upstream. So I'm not going to talk anymore today about working in the upstream, but it is something that you can head towards when you want to steer where the kernel's going in particular areas. So moving on from that, we're now going to look at just some organizational structure within the kernel. So firstly, I've talked about mainline, and mainline is often a term used for the kind of production branch within a company. It's not the best term to use because it will confuse matters when you talk to upstream kernel engineers, for whom the mainline is always going to be described by the website kernel.org, where it's actually labeled. It says mainline and it gives you the current version number. The mainline, in this sense, is the most recent kernel, including release candidates, published by Linus Torvalds. And in actual fact, even between these release candidate releases, the Linus Torvalds Git repository is the main line for most developers. So that's the point at which code has been included in the Linux kernel and will go out in the next release. You'll notice we also have the latest release button. So where we have a release candidate as the main line, the latest release will be a one older, the stable. And then we have all the long-time support kernels listed on kernel.org as well. So within that kind of development cycle, the front page, as I've hinted, gives you a description of all the kernels that are currently being maintained by Linux kernel developers. So we've got the most recent stable release, and we've got the various long-term supports, including when they were last revved. And then you've got Linux Next, which is a test kernel that developers use. It's basically a pre-merge of all the features that people are aware of that might go into the next mainline kernel. All of the data on the front page is also available as an atom feed. So if you are working on long-time stable kernels and you want to be informed of new releases, you can subscribe to the atom feeds and you can see all the information that gets shared, keeping you up to date in when releases are made in a sort of snapshot view. Who contributes to mainline? So this slide is one that is awkward for me because I have to change it. Certainly, I usually change it every time we get a LTS release. I might be one version behind at the moment. It does change. It's not always exactly the same names. But as of 5.15, these were the top 16 corporate contributors to the Linux kernel. They're not in order, they're kind of clustered. So we have kind of ARM ecosystem in one side and Intel ecosystem in the other side, and distros in this corner. So and cloud vendors on the right. So it's not ordered by importance or who provides the most information. It's just roughly clustered by topic at present. And in terms of organization, we have that kind of practical level of organization. We have kernel.org and the Git servers that are linked from it. There is a main mailing list, the Linux kernel mailing list, which is an enormous high volume mailing list that almost everybody should be subscribed to, but with filters, and we'll talk about that in next week's session. There are also dozens of other mailing lists for specific subsystems. And for ARM-related discussions, there is this specific ARM Linux kernel mailing list, which is shown there. But disregarding all the physical assets and servers and everything else, the strongest organizing force across the whole of the Linux kernel remains Linus Torvalds. He is the maintainer of the whole of Linux, and it is his tree that defines what Linux is. However, Linux got far too big for one person to do all the maintenance of decades ago. There are different architectures, subsystem, patch counts into tens of thousands every couple of months. There's no way one person can handle all of that. So Linus has a whole bunch of different types of maintainers around to contribute to the maintenance of the system. So we have things like subsystem maintainers, driver maintainers, file system maintainers, and architecture platform maintainers. So Linus typically only accepts code from other maintainers. He doesn't take individual patches that go on the mailing list. So the maintainers tend to pick up code that gets sent to the mailing list as emails, convert it into Git, and then send Linus requests to accept that code. There are a lot of Linux kernel maintainers. As of 5.18, when I last ran this little shell script fragment, there were over 1,600 maintainers. And these are individual. This is not Some maintainers wear multiple hats. They maintain a couple of different subsystems. So this is not the number of things that are maintained. This is the actual number of unique maintainers. And large patch sets, if they are touching different subsystems, may involve multiple maintainers in the process of accepting it, which we will discuss a little bit more as we go through. So to show this kind of diagrammatically, there are quite often kind of hierarchies of repositories. It is fairly flat. Most maintainers are able to, or at least within one level or two levels of Linux, but there is a hierarchy that will pop up. So at the top level, we have things like subsystem maintainers. So subsystem maintainers are probably the things that you will think about when you're doing vendor tree enablement. So we're talking about things like the pin control, GPIO, regulator, I2C, NVMe, all the device driver families, if you like. And within those subsystems, you will occasionally find sub-maintainers. For example, the interrupt subsystem has an ARM interrupt driver maintainer. And additionally, there are quite often very, very significant drivers, ones that are almost distorting the landscape. So the designware USB 3 controller, DWC3, is an example. It's a very commonly used macro cell that it can be integrated in different ways. It has little wrappers around it. And so although we do have a USB subsystem maintainer, there is additionally a DWC3 maintainer who focuses on DWC3 patches, collects those together and passes them on to the subsystem maintainer. The same is true for a couple of other common bits of ARM IP, the PL families. So it is not the case that the subsystem is necessarily the top. For small systems, GPI, I think, is an example where there's a extra viewer and a maintainer and a couple of others, but ultimately it's fairly flat. There aren't any distortively large drivers within it. But yeah, you do see this hierarchy from time to time of maintainers that send pull requests to subsystem maintainers, and then they gather everything together for their subsystem and send it up to Linus. There are also, while I'm discussing subsystems, we've used maintainer in the singular. There are also subsystems which have maintainers, and where you have multi-maintainer subsystems, the rules may be different for different subsystems. It is not a homogenized behavior. We're describing the commonalities in this training, but it is not the case that every subsystem acts the same. And where you have teams of maintainers in particular, sometimes they take it in turns to hoover up patches, sometimes they have different roles within their maintainership. You can learn all this from kind of watching the mailing list, and if you're really stuck, you can just ask. It's email that you use to communicate. On the right-hand side, we have some other aspects, things like the architecture maintainers. So every directory in /arch will have one or maybe multiple maintainers. So that's where ARM, ARM64, PowerPC, and so on all sit. And then on the right-hand side, we have feature maintainers. And by feature maintainers, the blurred boundaries between features and subsystems, these are basically things that have very significant software aspects. So networking does have Ethernet drivers, but ultimately there is a tremendous amount of additional in-kernel software to manage networking that is much, much more complex than just Ethernet drivers. Device tree is a feature, software feature. Block devices and several other examples. They will also have their own maintainers. File systems tend to sit in this side of the world as well, which are hierarchied. Each file system belongs to the VFS layer. So ultimately, once you've got this tree, there is that route from Linus to get upwards. And there are files in the kernel to help you figure out who to send emails to push things. Maintainers' roles are to do things like we have to check that the coding style matches that of the kernel for a number of different reasons, but it's there. Consistency is expected. Maintainers should be observing when features are contentious and seeking to build consensus about the right way forward, together with the features proponent. And assuming that they're technically relevant, they're sent to the right maintainer, and so on and so forth. The reason I've spent so long describing maintainers is our second key point for today. Maintainers are the only path. They are the only route to get code from your downstream source to the upstream. And a maintainer in that role has to be viewed as a gatekeeper because of those responsibilities for consistency and quality. They're a gatekeeper. And so the only way to get your code upstream is to persuade a maintainer to apply it. I am using a rather than the, because if you end up working with kind of unresponsive maintainers who don't communicate with anybody, there are some routes around kind of failed maintainers. Or, you know, when you've got maintenance paths that are effectively overgrown, can't follow them, there are routes around, but you do have to persuade a maintainer to apply it, period. So if they ask you to change something, the default position should be to make the changes that you have been requested. Although obviously if you think the request is misguided or wrong, you can carefully argue. Maintainers sit on the public mailing list just like your contributions, and they expect to be seen making reasonable decisions. But yes, if there's no misunderstanding, if they've asked you to rewrite something, you're going to have to rewrite it if you want the code to land upstream. And it can be a difficult thing. You know, if you want a feature to land upstream, you have to accept this, that the necessity to persuade a maintainer to apply it means that if they're declined to apply it because they're asking for change, even if you consider that change to be small in comparison to the value of the patch, if a maintainer is asking you to change it, it's not going to be accepted upstream until the change gets made. So you have to accept it. And the reason, or the thing that makes it easier to accept, is that usually that does improve your code. Either by making it more maintainable, that's one of the most difficult ones, because if you're new to upstreaming, the definition of maintainable may take some time to understand, because it's a very long-term view, maintainable. But yeah, it does usually improve your code. And the final observation, just to be absolutely clear and explicit about it, is your schedule has no meaning. The fact that you promised your manager that you'd get it into kernel 7.2 doesn't have any role in persuading maintainers to accept your code. It's not a reason to accept your code. Your schedule does not have a meaning, because there will be another kernel along in 10 weeks' time. So maintainers always are able to have that position that the next feature can wait. Bug fixing is different. Bug fixing can be taken anytime, although even then, the bug fix does have to meet the quality standards, and normally the proponent of the bug fix is the person that we ask to make changes. So that is the kind of overview of what upstreaming is and how it is organized. For the most of the rest of today, we will talk about the kind of mechanical processes behind preparing patches, creating patches, or preparing to create patches, creating those patches, posting them, and so on. The cycle of patch sets on the main list, culminating with a kind of worked example of that. So we're going to push forward into patch preparation. I'm sorry, I'm just checking my clock because I'm very aware that the clock on my laptop is 10 minutes slow. Okay, so how to upstream preparation. Preparation at this point is almost before you have started writing code. So you have been asked to contribute to the Linux kernel. If you are upstreaming, you may well already have a driver from the vendor tree that is functional and potentially very well tested. But you still, when you've been given this role of upstreaming, whether you are writing a driver from scratch or you're taking an existing driver, need to accept that maintainers are going to ask you to change it. So preparation is all about doing a little bit of research ahead of time, so you're not just throwing a driver over the wall to have it be picked apart as unacceptable in a variety of different ways. So you're doing some work to make sure you understand how the upstream kernel expects drivers to look. So obviously you check that the feature has been put in the right part of the kernel tree, that's in the right directory. In particular, it's less of an issue now, but there was a point at which there were a substantial number of drivers in Arch ARM for running certain specific kind of platform-specific devices, configuring clocks, things like that. Over the last 10 years or so, strong subsystems have built up to manage most of the commonly found features of a SOC, power control, clock, and so on, into subsystems. So it is now the case that although there may still be a small number of legacy drivers in Arch ARM, and even they are being chased out diligently by the kind of last of the device tree conversions, don't copy that pattern. You know, maintainers for Arch ARM will reject any code that could or should be put somewhere else, like in drivers. ARM64 has always rejected code that doesn't belong in Arch ARM. So you look at where the right place is, you try and find the subsystem. If you can't find an appropriate subsystem, you might look at some of the kind of catch-all places like drivers SOC, which is usually for kind of SOC glue peripherals. But you find the right kind of directory for it. And then from that directory, you can both look at the latest code in that directory, in the latest kernels, the upstream kernels. You can look at the most recent kernel APIs that are used by those drivers. You should look at some of the existing upstream drivers. And there's two types of drivers I particularly recommend looking at. One is recently added drivers. So when you look at a recently added driver, that's the one where the maintainer is applying all their most recent knowledge. And maintainers improve as developers over time as well. So drivers that they may have accepted 3 years ago, but they have learned to have maintenance problems that haven't yet been fixed, do mean that a driver added later needs to be better. It needs to be at the highest standards, not at the lowest standards of the subsystem. So it is reasonable to look at recently added drivers because they would be expected to meet all the most recent expectations of that subsystem's maintainer. The other driver I like to look at is one of the most heavily maintained. It's very common for one of the drivers to be more heavily maintained than others. In the case of backlight, for example, the PWM backlight is a commonly used thing to build a backlight on top of PWM. And then there are lots of specific backlight devices as well. So the PWM driver is close to a gold standard driver because it implements most of the features that we expect to see in drivers. So it's another good one to study if you were trying to come up to speed in that area. It's also worth looking for drivers whose hardware data flow is most similar to the hardware you're working with. So for example, if you have a hardware random number generator that simply reads from a single register, there's not much point in reading a driver for a hardware random number generator that can DMA megabytes of newly generated random data into things if all you've got is a register FIFO. So those are the kind of things you want to look for: recently added, well maintained, and you want to look for similar hardware, which could give you 3 or 4 drivers. But by combining that information together, you can get a good sense of how a driver should look for your subsystem. This also makes it sound like it's a kind of 2-week research project. You know, you can do most of that I've described in less than a day once you've got the habit of reading code. You probably should also kind of search and read mailing lists for recent contributions. You could look at that recently added driver and actually look at whether it arrived on the mailing list fully formed or whether it went through a review process and what changes were asked for, because that's a recently added driver where changes have been requested are basically guiding your mistakes that you don't need to make, because you can copy and apply the feedback preemptively. So getting involved in the mailing list, at least reading it, can be worthwhile. Most of them are archived, so you can read the archives. And while you are working on that subsystem, you can also stay subscribed to that mailing list if you would like to. There is also some kind of experiential building that you should do of your own. So Obviously, documentation. You can read about documentation for the subsystem, how the kernel APIs involved worked, and so on and so forth. If you are doing upstream of drivers, then device tree is likely to loom large for you. So actually, I might just add a bracket 64 there. So you've got documentation. When you work with device tree, there's the directory containing the bindings documentation. You can look at bindings for other similar hardware as well. And as well as reading the binding documentation in device tree bindings, you can also look in boot DTS and actually look at concrete uses of the binding to help you understand what it does and how it works. If you are very new to device tree, it can be worth subscribing to the device tree mailing list for a period of time. There is documentation, which I'll show you about in a moment. But it can also just be that the device tree maintainers, the reason that you get the dual license comment that I showed you at the beginning is because I don't doubt for a second that Rob has said dual license several times a week for several years. And subscribing to device tree mailers lets you see those patterns, the mistakes that are so boring that device tree maintainers just want to go. So yeah, it's worth looking at for a couple of weeks just to soak up the current fashions and culture. It's probably not one to stay involved unless you want to contribute to the device tree subsystem itself. So, as we've mentioned, we're looking at those best practice drivers. And part of the reason to do that is that kernel structures and APIs are continually changing. Not only can you as a developer grow out of date if you don't do this, but particularly if you've picked a vendor driver that was developed on an older kernel, there is a good chance that that driver, however well tested, doesn't take advantage of all the new APIs that the kernel offers. And so as well as going through this kind of review process, I almost view picking up a vendor driver and upstreaming it. You start off by doing a review as close as you could to how a maintainer would look at the code. And then you act on your own review, you tidy up the driver, you test it again, and then you share upstream. And one of those processes that you'll be doing is API updates. You'll be looking for new APIs that have been introduced that you could and should use. I would always recommend joining a mailing list for the subsystem involved. Again, you can find that out from the maintainers file. And just while you're working, having a flow of small reviews and small items passing your desk, you don't have to read every word of every email, but it can give you a sense of what the subsystem is about. If you can't find an appropriate list, you could look at the ARM kernel main list, but I personally view the traffic level as just too high. We will discuss next week how we deal with main lists whose traffic levels is too high. And then finally, you can look for kind of real-time chatter to see how some of the aspects of maintainership happen behind the scenes. And ARM Linux on Libera chat is a good starting point. So that's your preparation. That is getting ready to be productive. At that point, in between these two bullets, we kind of assume that there's been some development, some tidying up, and the C code is now kind of approaching ready to go. But we still have some mechanical work, if you like, to do with creating the actual patches. So first up, these are links to kernel documentation. So kernel documentation is quite extensive. It is itself a subsystem that is frequently maintained. And parts of the kernel documentation include guidance on how to get your code into the kernel, how to get the source tree, describe your changes, and so on. These are all things that you should read before your first contribution. You should perhaps reread after a little bit of time to see if there are bad habits forming. But yes, it's documentation definitely worth a look. There is similarly a submit checklist, which is a way to try and make sure you don't forget to do proper testing before you ship, or make sure things work, and so on and so forth. So both of those are valuable documents. When you are working with device tree, so there are multiple ways to describe ARM hardware. ACPI and device tree being preeminent. So it's possible some people have joined us are going to be ACPI based. ACPI does not have the same strong level of documentation as device tree. There isn't as much that I can point you at in terms of resources. There are some resources in the kernel, of course there are, and you can search for them. The reason device tree comes out very strong in this course, partly for its obvious importance in the ARM ecosystem if you're not making servers or PC-like devices, but also it is well enough documented there's something for me to point at. You know, we have guidance on how to write effective bindings. It's very short guidance. It's just do's and don'ts of how to construct device tree bindings that are likely to pass with the device tree maintainers. And then similarly, there's a document about submitting patches, which explains the ordering in which you want a patch set to arrive. I'll show you that at the end of today's talk. So one of the things about casing patches is that people do expect them to work. Let's go straight in on that one. They expect the patches to have been reasonably well compile tested, and if they have not been runtime tested, it should certainly be disclosed. And the general explanation is it has had some level of runtime testing as well. So there are two goals with the testing. One is to make sure that they do the good thing they advertise to do, that they make your hardware work if you're upstreaming a driver. The other thing you may be needing to demonstrate is that they don't break things easily. So that means that they don't leave the kernel uncompilable if they're enabled and things like that. So for basic testing, good starting points are the multi v7 def config kernel if you're using ARM, and the simple def config kernel if you're using ARM64. Good test to make sure your new additions haven't broken anybody else's build. You should run with your driver enabled and disabled with both of these things to make sure you haven't added anything to header files that can lead to unlinkable code. So you can run this, and if you've got multiple options, you should test the option space. If you're adding new drivers, then things like all mod config is a very, very good test to be running, since heavily modular kernels are more likely to see symbol errors and things like this. And do make sure when you do an all mod config build that you do hoover up the warnings, because certain of the link errors happen at the last stage in the build where it looks to find out if the modules actually work together and can be linked, and it comes out as a big pile of warnings at the end if you get that wrong. So finally, when you get ready to push the driver upstream, one thing that is worth mentioning is that if you are actively upstreaming, it is possible that the upstream kernel is not yet capable of running the driver. Ideally, that doesn't happen, because ideally you approach upstreaming by turning on the base features first. But in principle, you know, if you want to introduce a driver where not all the components to make it work are present, maybe you can't change the pins into particular modes and things, that doesn't absolutely prohibit you introducing it. Ideally, you can test it on things like Linux Next alongside other drivers that come up in the same kernel version. And obviously, if you do depend on other patch series, you should disclose that in the covering letter. But the fact that you can't run your patches alone aren't enough to make the mainline kernel work, don't necessarily have to be an inhibition, providing you can point on the patches that you did test with to make it function and explain why it's okay to accept them independently. The thing that can take a while to get the handle on is splitting up patches appropriately. So when you submit patches, as we mentioned at the beginning, your goal is to persuade a maintainer to apply them, and that it's better to apply them than to ignore them. And the patch series is one of the ways you can present patches so that maintainers can understand it and accept pieces of it most comfortably. It's almost like telling a story to give you a sense of chapters within the changes that you're making. It's very, very easy to write a patch to, oh, I've seen a bug, I fixed that, I fixed it, and you send a patch that says, so this driver cleans up OMAP 2 plus, it does this, 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 and this. That is not a patch that is necessarily going to make a maintainer very happy for a number of reasons. But one is simply that it's big and unnecessarily difficult to review because each individual change could have been shared separately. So splitting them up is a way to make it reviewable. You know, the fact that you are technically and socially influencing a maintainer means that you do have a responsibility to make your work as comprehensible as possible to that maintainer so they can review it effectively. Splitting things up is fundamental and is a very, very common early mistake to combine everything too much. So each part of the story should be its own patch. And once you split it up into these, I'm calling them chapters in the story, you then may want to reorder the patches to be in the best order for the story. I usually like to line things up, say foundational tidy ups and things that are easiest to review are at the front of the patch set, with bigger stuff coming later or more complicated things coming later. It doesn't necessarily mean you're ordering the patches in the order you wrote them. In fact, you shouldn't order patches in the order you wrote them. You should order them in a manner that makes them easiest to review. Just to explain, so small patches are definitely easier to read. You know, if you have a small patch to tidy some small piece up, that you can read all of it and be confident it's correct, then the maintainer can just put a tick next to it, be ready to apply it, and move on to the next patch. The same code tangled up with other things is harder to review because you don't know which bit's doing what. It's more time-consuming to review. So small patches ultimately are less likely to be ignored. Now, I've put ignored in quotes here because some maintainers do ignore overcomplicated patches, but most have actually just decided to do it later. They've looked at the patch, they've said, oh, that's going to be very time consuming to review, and they deprioritize it against the other smaller patches that are easier to work with. So it's not being ignored as an act of dismissal. It is more being put on a I'll do this later list. And so to have a clear example of the story, this is a 3-patch set of theoretical changes to an OMAP 2. I mean, clean cruft is a terrible, terrible description of a patch. But because I'm being ambiguous, I haven't got more specific. So this is a small tidy up, basically. It should not be called clean cruft. It should actually describe the nature of the tidy up. But yes, this is probably a cleanup that doesn't have any significant functional effect, doesn't fix a bug, doesn't do anything else. We've then got fix a bug if probe fails. This is probably a memory leak if you have a probe. Sorry, this is bug. So this is calling the bug macro if probe fails. That should definitely not happen. So we avoid doing that. There is a debate about which order these should be in, because avoiding calling a bug macro if probe fails might be a patch that gets backported. But even then, if it's well structured, it doesn't matter too much because the patches are semi-independent of each other. And then finally, we have an update to use new I2C APIs. So ultimately, this patch ordering does assume that this first patch, cleaning cruft, is some kind of bug fix, because if it wasn't, you'd put the bug fix first. And in fact, I might update that in the next version. And then this one, which is a non-functional change, but is updating to newer APIs, is a good change to have, but you tend to put that last because that is the right order for the story, and it's good for backporting to have it in this order, et cetera, et cetera, et cetera. And it certainly would be annoying to have updates to new APIs and a bug fix and a cleanup all in the same activity. So in terms of splitting patches up, so a little bit more advice on this. So we're splitting the patches up based on the reason and function of the changes. It's perfectly okay for a change to impact many files. It's even okay for patches to impact multiple subsystems if they are making certainly mechanical changes. Normally, I would change, if I was doing mechanical changes, I would tend to have all the changes to a subsystem, all the drivers in one patch, unless the maintainer asked me to do them individually. So if I went through and applied the same transformation, new API or something like that to all the drivers in a subsystem, I would tend to do that in one patch to start off with. Some people wouldn't. Some people would do individual drivers, and that's fine. It will depend on the preferences of the particular maintainers you work with. Sometimes you might be asked to split it into multiple patches, and that's fine. You split it into multiple patches and you do it on the next version. One thing that is absolute, however, is that every patch you make should leave the tree compilable. This is a property quite often called bisectability after the git bisect command. So git bisect allows you to automatically hunt for regressions by effectively binary searching through the version history between a known good and known bad patch, looking for the patch that introduced the problem. If you can't build some of the trees, git bisect can find ways to work around it, but it is inefficient. And it also means that it may not find the exact patch that introduced the problem. So maintainers care a lot about bisectability. They really would like the kernel to be compilable at every step along the way. It's part of making the kernel more maintainable. And that implies that when you split your code into patches, you do have to not make mistakes. You can't take working C code, split it up arbitrarily and then not test it, because if you don't test it, you may well have introduced compile errors midway through the patch set. So that means obvious things. You don't use variables in one patch that you introduce in a later patch, and things like that. They're relatively easy to make mistakes to make, so it's why testing matters. But yes, when you split patches up, that doesn't mean taking a C file and treating the logical structure as more important than the C structure. The being compilable, the not being broken, not regressing in the middle of a patch set is a important property. Let me just check what's going on this one. Yeah, okay. Okay, so next thing we're going to have to do is describe the changes that we're making. And that involves writing a good patch subject line and a good patch description. So almost all patch subjects are tagged with the subsystem you're contributing to, and then a short description of the changes being made. There is also this section on the left, the square braces and the patch. So there's a number of different formats we see here. So we can have patch and what looks like division. This is saying this is the first patch in a series of 11. The 0th patch is the covering letter. It's the one that doesn't actually request it. It doesn't contain any changes. It's simply descriptive. And then patch 1 through to patch 11 are the specific individual patches we hope to have applied. When you are doing second and third and fourth iterations of patches, you need to add a version number. So you end up with patch v3. So this example here is a standalone patch. So this one is a patch from a series. This is a version 3 of a standalone patch. If you are doing a multi-part series, there is still a version number and it sits between the patch and the number here. And then finally, there's a type of tag called RFC, request for comment, which is a mechanism to request comments on code that you would like to introduce to the kernel. It does not mean this is a rubbish driver, please tell me how to fix it. You may get people helping you with that, but it's usually for advice on the best technical direction you can have. And If your goal is to get advice on technical direction, then submitting a patch that's badly structured, hard to read, contains lots of old APIs and isn't split up correctly, isn't going to get you the high quality review that you need to get your design decision. So RFC does not mean send crappy code. RFC means you are seeking some kind of technical guidance on a technical decision that you need to make, but it doesn't actually let you off any of the kind of quality criteria. And just to show this in context a minute, this was the patch set we were looking at. Where's the threads? This is the patch set we looked at the beginning. So you can see we had that covering letter. This is patch version 4. It's a 6-part series, and we've got the 6 different individual patches coming through. Just to tie that back to those subject lines we were looking at. And then in these things, we have specific descriptions of what's being added. And that gets us to the commit log. So after we've got our patch description, the commit log, the patch description is very, very important. A process of technical and social influencing. The commit log is your strongest chance to provide that influence, to show why the patch needs to be. And in that regard, sometimes you do just say this patch adds this feature, but that is not taking the opportunity to explain why the kernel will be better with your patch. You know, technical and social influencing to persuade a maintainer that the kernel will be better if they apply your patch than if they ignore it. So particularly if it's a bug fix or a small change to an existing driver, then you're looking at explaining why the patch is needed, what the patch implements and how it does it. So a good example, the conditional in this function did not handle this case and it breaks on this platform. That's why there's a problem. That's why the kernel will be better if you apply this patch. So add an additional conditional in error path 2x to handle y. That's what it does. That allows us to go and read the code and makes it easier to review because we've got some idea of what it's doing. That's the example of commit logs that can help you communicate to the maintainer why they should take the code. Every commit is expected to have a useful and comprehensive commit log. And more than that, the reviewer will complain if your patch makes changes that cannot be predicted from the commit log. So even if there is a good change at the bottom of a patch, if I haven't seen an explanation of what it's doing there in the description, I will ask the maintainer to either split them correctly so that you can split this unrelated change from everything else, or I'll ask them to describe why it belongs in the patch in the commit log. And finally, this may seem tedious occasionally, but it's not just for the maintainer. You know, the person who is most likely to go digging for trouble in the driver in future may well be you. You may well be having to debug this when a problem emerges on a high-profile system. So the commit log is not just for maintainer, it's also for whoever comes and tries to fix trouble later, and that may include you. You can always use git log and look at the version history. There is, you know, probably millions by this point of examples of commit logs in the git history. There is plenty of examples for you to copy. So what it should contain as a checklist, it should say why the patch is needed. It should say what the patch does and why. It might want to consider mentioning what the patch does not do. So if you have deliberately decided not to implement something or to not address a particular aspect, say so, because the maintainer is going to ask you why it's not there. And if there's anything in the patch description, if there's anything in the set of changes you want to make that is not in your patch description, then either remove it or put it in another patch, or you know, describe it in the commit log, change the commit log to mention it, but don't try and sneak any changes in because that tends to attract attention. Oh, I got some examples coming up. Yeah, okay, so there seems to be quite a long time between examples, so I will push towards examples as we get through. There will also be some tags that you add at the bottom. The most important of these tags is the signed off by tag. That's one that you add to every patch you want to submit. And it's saying that essentially that you have the authority to contribute it to the kernel under the license. We will look very specifically at what the tags mean next week. But for now, that signed off by is an assertion that you have the authority to add this code or submit this code for the kernel. Other tags that may get involved are reviewed by, which is used to indicate that somebody thinks the code should be applied. Again, we'll look at exactly what that means formally next week. Tested by, somebody says the code works. Act by is something that maintainers quite often throw about to say, this code can be added to the kernel, and I hope some other maintainer is going to apply it for me. Just to, again, put that into the, excuse me, the examples we've seen here. So this patch that was sent in by Robert from the set includes the signed off that says that Robert has the authority to share this code. It also includes a reviewed by. So in this case, I suspect that the code would have been shared, and sometime in the previous 3 revisions, Dimitri offered his reviewed by, and it becomes the contributor's requirement when you submit new versions to collect tags that have been added in previous versions. So this review would have been done previously, and Robert's collected it for the next version. And that's basically a reminder to Dimitri that he's already accepted the patch. He doesn't need to do any additional work to review it. So as an aside, while we're talking about signed off bys, you are expected to be using your own name when you contribute to the kernel. Although it is not enforced, if people are using pseudonymous names, they are not encouraged or expected. You are expected to contribute with your own name. So as an aside, you're expected to contribute with your own name. Every patch you send to the kernel has your name on it. It does not, well, it should actually, in the signed off by, also have the sign off of the original author if you're upstreaming somebody else's code. You should negotiate that before you send it upstream. But it has your name on it. Your name is the sender. You are the person saying this should be added to the kernel. You would probably like your name to be associated with high quality patches, and you certainly don't want your name to be strongly associated with poor quality patches, because that will make upstreaming harder. Once people recognize that you do shoddy work, their maintainers are more likely to defer your work to review for another day, because they know it will be time consuming. They know it will not be the best use of their time when there are other patches that haven't been written by somebody who has a history of sending poor quality patches. So these things do get noticed, they do get remembered. When you send out emails to the kernel mailing lists, they are archived essentially forever. More than that, they are also on high value web servers that are strongly linked to. So mails about the kernel will rank quite highly on search engines. You don't know which patches of yours they're going to find, but if somebody puts your name and the word patch into a web server, there is a very good chance they are going to find your kernel contributions. And in jurisdictions where it's legal to do so, you could also be pretty certain that whenever you apply for a job, somebody types exactly that into a web server before deciding whether to offer you an interview. So it has your name on it. It is important. You do not know what of your patches the search engine is going to select when somebody types your name and patch. I do this myself kind of experimentally from time to time. The last time I did it, I didn't pick up anything that embarrassed me, but I did pick up an obscure patch from 2014 that I had completely forgotten ever having written. And it was a patch where somebody replied with a much better idea, and the much better idea went into the kernel. Like I say, no shame, I'm very happy with that outcome, but I'm surprised it was the piece of my kernel work that the search engine selected. I didn't know why that was. So when you are interacting on the mailing list, it is important to be mindful of what you do, both in terms of shipping high quality work and, as we get through to it, how you handle reviews, how you work with reviews. how you make yourself easy to work with, because people will notice. If you get a particular review that gives you a emotional reaction, that is a sign that you should take a keyboard break before replying. Having code reviewed, particularly for the first time, is somebody saying that your work's not good enough and it needs to be improved, and that is difficult. If you feel an emotional response, try to take a break. It's really easy for me to say that right now. We're in a training environment. You'll go, oh yeah, I can take a keyboard break, no problem. When you actually have the emotional reaction, it will be much, much harder for you to do that. So you learn to work with these things. It's not a big deal. It's not something you have to be frightened of or worried about. But in particular, that emotional reaction is a suggestion it's time to have a short break. Finally, it's not just your name on it. In almost all cases, it will have your employer's name on it as well. And poor work with your employer's name on it has a reputational risk to your employer. The final thing to point out, and this is an approximate, it's a paraphrase of statements that Greg Crowe-Hartman makes quite a lot. If you work for a company, if you are paid to contribute to the kernel, then you have got a job contributing to the kernel. And if you've got a job contributing to the kernel, then you'd better know how to do it. The assumption in the kernel community is if you are paid to contribute to the kernel, you are a professional, you are going to be held to a higher standard than hobbyists who are cutting their teeth. If certain maintainers have a choice between mentoring a hobbyist and mentoring somebody who is already paid to be a kernel developer, they're going to mentor the hobbyist. So yeah, you've got your employer's name on it, which has a cachet because your employer will be well known in the industry, but it also means that they know that you're doing it and being paid. So you have to do a professional job. This is not something I put up to scare people, but there is reputational risks to companies if they continually upstream in a non-cooperative manner. In this case, it's not that the company involved, which I hope I've scrubbed out properly, this was actually an interesting case because they were being successful. They were successfully upstreaming, but frequently introducing bugs, which is why Linus took notice of it. The more common approach, if you do a poor job of upstreaming, is you never actually land patches. But there is that risk. You have to pay proper attention to things. The next couple of slides are quotes from submitting patches. It's that reminder about the patch and the tag and the version numbers and the counts through it. So I've already advised you to read submitting patches. These are available for you to read at your leisure if you want to as you work forward, but I'm not going to verbalize everything on these slides. They're just resources that I've put in the slides for you to look at. We now just have a couple of examples grabbed from mailing lists. This is probably the single email that has been most influential over my own upstreaming work. And it's advice on how to write an effective commit message. So in this case, a patch was put into appropriately subject. It was designed to improve the panic timeout calculation. But what it says is we want to calculate the blinks per second, and instead of doing this, let's use 4 instead. And it says so the user can see 2 blinks per second, which is not a bad thing, but it doesn't provide the reviewer any comprehension on why 2 blinks per second is a good thing, why it's better than the number of blinks we currently have per second, which is presumably 2.5 blinks a second. So it doesn't express, it expresses what the patch does, but it doesn't give you any clue as to why. And this classic formulation, currently the code does this, which is bad because of this. We can improve it doing this, and the change is correct because of this. That phrase or variants of it, currently this happens, it's bad because this is how to fix it, and so on. You will probably, if you look back through many of my patches, you'll recognize that pattern, not quite in this form and not as explicit, but the idea that currently this happens and it's bad because this. will appear over and over in the first paragraph of many of my patches. Whether for the kernel or not, it's just a good habit that I've adopted. And yeah, this was from a very experienced kernel developer who is trying to suggest that this is the most common idiomatic changelog style we use in the kernel. So an example of a good commit message is here. Now, this is not in the currently this happens because this, although you can see the currently in this otherwise at the bottom. So this is on this particular platform, these two buses are 8 bits wide. So we need to update the bus width property in the device tree to reflect that. Otherwise, the driver will operate with a default bus width of 4. Now that's quite concise, it's 2 sentences, it's not a long, complicated commit message, but it covers all those bases. This is the currently. This is effectively A from the previous slide, and this covers all of B, C, and D. So although it's not written in the currently form, it is a very good commit message. It covers everything that is necessary for a maintainer to go, oh yeah, and apply the patch. Oh, what's going on there? So I've got a slide that's missing. Which I thought I had. I'll do the commercial break. I will go and fish that in a minute. Okay, so yes, I do seem to have a slide missing, which was a bad example. So I'll verbally describe the bad case. So the bad case was effectively somebody venting about the feedback they had received. So they had received feedback and they said, "Are you happy that the kernel will never get better if you don't apply my patch? Please let me know if that's what your goal is." And that is not effective at technical and social influencing. The declining to make a change. It's because it's review. Sorry, I beg your pardon. Ignore that entirely. This will come up. I've got my slides in the wrong order. I beg your pardon. So sorry for that aside. It will come up later. You'll probably recognize it when we get there now. Very briefly, I'm just going to launch into a small aside about support for anything that's come up in this course. So the reason I've dumped it in the middle while I'm mid-flow describing how to upstream is because when I said it at the end in previous courses, people forgot it. And parts of it are quite important because it is how you can access post-training support. You know, when I'm no longer in the room, when you can no longer put questions in the chat to me, you still have an opportunity to contact me if you would like it. So training at Linaro comes out of the developer services team. So it's a commercial activity. Although we're delivering it to members for free, I do also get paid to deliver this and many other topics for our developer services customers as well. The downloadable catalog is here. So if any of folks and members wants to look at the downloadable catalog, if you are Hub and Core members, then you can talk to your training managers and try and get material from the catalog put into a package that can be delivered to you. If you are a group member, training is available to you on a commercial basis and through this member services. So you get invited to member webinars, which is the same content as we would deliver in our professional services capacity. But you have access to the full catalog if you want to as customers. Club and Core members, we can come in and deliver this as part of your membership fee. And then finally, we have Linaro Developer Technical Support. So Linaro Developer Technical Support stands behind the work of Linaro, all the work of Linaro. So whether it's by maintainers, whether it's by me coming in to do this training, LDTS is there to stand behind all of those activities that we do. So it's how you can get support on anything related to Linaro, including this training. If you want to gain access to that support, you have email, web browser, and I've forgotten everything, just type Linaro support into a search engine. So those are the 3 options. But by this search engine idea is I'm aware that some of you won't remember the exact spelling of the email address. But if you can type Linaro and support into a search engine, all the other mechanisms to contact support will be put in front of you in the top, hopefully 3 or 4 results. But if you prefer, you could just remember this big, long, white string, support@lenaro.org, and email to that will attract the attention of both myself and my team. So if it's, I want to know more about this slide, can you expand on this point? Basically, if you can give me a slide number, I'm happy to stand behind any piece of training that I give to anybody. So that moves us back into the regular scheduled feature. And we're now going to talk about what happens in this final stage of trying to get your patch in front of the maintainers themselves. So during the creation process, you've created a Git sequence. So you've committed to Git and you've got all the pieces in Git ready to send out. From here, we're talking about how to use the Git tools to construct patches in the canonical format that I've shown you when I jump into that patch set from Robert from time to time. So Git format patch is the first step. So this will take patches out of Git and prepare them as effectively prototype emails. So they have all the header information, the subject line, the date, ready to be sent via a mailer. So Git format patch prepares a collection of patches on your local file system that you can go through final reviewing. So Git format patch has a number of command line options, one of which is ---- cover letter, which is how you can generate a template for patch 0 of the patch set, which you then hand edit to provide the cover information and you're ready to go. You have scripts which you can run over the patch set. So scripts /checkpatch.pl ---- script pointed at a file name, the patches that have been generated by Git format patch, allows you to run final pre-flight checks before you post anything to the mail list. You should always run it through checkpatch, if only because it really frustrates maintainers if you don't. I like to use checkpatch as I work as well, so I've set up Git hooks so that checkpatch runs every time I commit to the kernel repository. I also have overrides so that if it gives me a false warning, I can work around it. But I usually do it at the commit point, but I also run it before I send anything out, just in case I've made any mistakes. Now, I've been talking for about 20 minutes about what happens between you finishing the C code and splitting up the patches and getting ready to send it. During the work associated with what I've been talking about for 20 minutes, maybe I introduced a bug, maybe I deleted a variable, I did something wrong. So at this stage, the very final step, it isn't a bad idea to build and test exactly what you are posting. I would tend to do that before I do the Git format patch, I have to concede. You can literally take a mainline kernel, apply your patch, and test like that. That's not expected necessarily. But yeah, you do need to build and test what you are posting. Effectively, the reason for that is that sending code that doesn't compile is a relatively rapid way to harm your reputation. You'll get away with it once or twice, particularly if you wrote an apology and explain how it could happen and that you won't do it again. But if you continually send uncompilable code, people again will associate your name with uncompilable code. And then finally, at this stage in creation, we have this script called getMaintainer.pl. So the first time we do Git format patch, we're getting a set of patches come out, and we can then use scripts /getMaintainer.pl to figure out who we need to post those emails to. Once you have, sorry, let's go back a sec. Once you've used getMaintainer to figure out who you're going to send those messages to, you then rerun Git format patch with --2 and --cc added to your Git format patch line, which will generate the final templates that you send out. So there's actually a slight bit of iteration. You run format patch, you run check patch, you do the builds, you do get maintainer, and then you add it to the 2 and cc of format patch and regenerate them. Once you have got that set up, you've now got template emails ready to go, you've written the covering letter, you can ideally use git send email to send that to the mailing list. So that will read the headers, so all the to's and CC's that you put into your git format patch will be absorbed. All the tags that you've added, any sign-offs, reviewed bys, anything like that, the email address and the tags will be absorbed and added to CC. So git send email will gather all that up and send it to your corporate mail server. Your corporate mail server may need a little bit of coercing to figure out how to integrate it with git send email. Talk to experienced colleagues, and anybody who's already working on upstreaming will be able to give advice on how your specific corporate setting can be set up to send emails. And while you're at it, you can also discuss how to send plain text emails with the corporate emailers as well. In terms of who you're going to send it to, like I say, there's this file called maintainers, which is the top level of the kernel and describes all the different kind of maintainerships, for example, in this case, the ARM port, and with these little tags. So M is the maintainer or maintainers, if there's multiple entries. L is the list. W is a website to find it, status maintained, and F is the files involved. So in this case, it's everything in /arch ARM. There can be, I think there's a few other files as well for some of the bits that are in drivers. There's also a handy script to parse maintainers. Maintainers is intended to be machine readable, and this is a tool to read it. In the simple case, you can say script get maintainer and point it at a single file in the file system. So in this case, we've pointed it at a SD host controller driver called foo, which I created myself as an example. And it comes back and tells you that Ulf is the maintainer. And I'm the author, which is hardly surprising given I wrote it as an example. And it also gives you the associated mailing lists, including the kernel mailing list. So that is the kind of minimum set of people, excluding yourself, that you would need to email. So Ulf would go in 2 because he's the maintainer. He's the person you expect action from. Linux MMC is on CC, as is Linux kernel. You should always send patches to a Linux kernel as well. So that would be the set of minimum people you should send it to. Alternatively, if you run it on the patch itself, you will see a tremendously large set of people. It's still picked out Ulf as the maintainer and marked him as a maintainer. But what's happened here is I had a patch which doesn't just contain the driver itself, it also contains changes to the make file and changes to the kconfig file. And that's where these other people have been picked up from. These are people who have got involved heavily in the subsystem previously. So you can see here that these top 2 people have made 4 or 5 contributions to the subsystem. The idea is if you can't find a really, if the maintainer doesn't show up or it shows up unmaintained, you can look for people who've made significant contribution in the past and copy them in the hope that they will review your code for you. Where you see people who've only committed 1 action in the past, you're much less likely to want to take it. But finding people who've been commit signers are good examples of people that you might want to copy because they might be willing to review things for you. So you can see here there's 4 commit signers who have reviewed other people's work in the subsystem. You probably need to go and find out why and figure out whether you're going to copy them in. But that's the 2 kind of levels. That one is you can't not contact Ulf. If you send a SDHCI component and don't copy Ulf, it will probably never be applied. These people might get involved in review, and you should perhaps look at the mailing list and figure out if they're commonly involved in review or not. That's patch posting. Once we've done the git send email, they have gone to the mailing list. They will be archived on the mailing list servers, as we saw with Robert's patch set. We're now sitting back and we're waiting for feedback. So first up, expectations. Maintainers are perhaps not in your time zone and are also very busy. They will not be replying to your patch within an hour. If there is no response after, say, a week, it is mostly acceptable to send a resend, just to send the patches out again, with resend in front of the patch. So instead of saying patch in square brackets, it says resend patch in square brackets. That's an argument, incidentally, to git format patch. So that whole patch and the v5 and other things, all of that is a tag that you supply to git format patch. We'll discuss the merge window next week. So this is a rule of thumb. If there's no response after a week, it's acceptable to resend. There are times when you might choose not to resend based on where we are in the merge window, and we'll discuss that next week. And secondly, be prepared for the feedback to be challenging. I think tough is perhaps the one thing. Challenging experience, because you are going to have to justify what you did and why you needed to do it. And if that wasn't explained in your commit message, you'll be asked, you'll explain, and then they'll say, put that in the commit message. And also, as you saw with the interaction between Rob and Robert, these things can be quite brief. Although you have to give detailed and direct answers, the questions will not have very many spare words in them quite often. It does depend on the reviewer. Some people are wordier than others. But yeah, people who review a lot don't waste words. And where you have particularly short things, misunderstandings are possible. If you don't understand the thing, then you can ask for more details. If you think the response is wrong, you can explain why you think it's the wrong thing to do. But do look, particularly if you're going to challenge a maintainer and say, I think this is incorrect, you can phrase as questions. You can say, this hardware does this, had you spotted that? You should also look to see if they've discussed it before with other people, if you can find it on the mailing list. And then the final thing, of course, that maintainer is expected to maintain the look and feel of the subsystem. So some of the changes they request may be cosmetic. And some of the changes requested by reviewers may be cosmetic as well. Firstly, don't take that as a judgment of your skills. Being asked to change the format or presentation of an idea is an important part of making it maintainable. It doesn't mean necessarily that you've done it wrong. It's that it'd be more maintainable if we show it like this. It's definitely time for that kind of ego check to make sure that you're not feeling too emotional about it. But also just to express what pragmatism is in this case. Applying a cosmetic change is so much quicker than discussing whether it's a good idea or not. You know, your job, assuming you've been asked to upstream something, is to get stuff landed upstream. And generally, making the changes that have been requested, if you don't disagree with them, whether you agree with them or not, it's easier just to do them. And then as you gain more experience, you may see patterns of particular changes and then simply adopt those styles to some extent. If you cannot understand what the comment means, you know, if you saw dual license and you just had no idea what Rob was talking about, firstly, have a quick glance at the documentation if you can find any to see if you can make sense of it. But if it still makes no sense, it is perfectly okay to say, sorry, I don't follow. And you'll get a slightly longer reply, hopefully. It is almost certain when you get feedback that you will have to redo your patches. It is not expected that patches land with that implicit version 1. You know, patches in version 5, 6, even mid-20s are not uncommon depending on how complex the work is. So you've got feedback. Feedback should always be regarded as a good thing. If you've got feedback, then you've got something to converge on. And if you're converging, then you are successfully upstreaming. You are taking down the barriers that stop your code being accepted. It is so much better to have feedback than to have silence. So you have to be responsive to feedback. First and simple reason being that is if there is unresolved feedback, if there is feedback that has been provided to you that you have not reacted to, maintainers are very unlikely to accept the patches, even if it's not from a maintainer, even if it's somebody else who said this line is wrong. Maintainers read that, and certainly when I read that, I tend to abort review and wait for the change to be fixed. So you should answer feedback quickly. just that ACK that Robert sent to say, I'm going to fix the next version. That's all you need to send back if you want to do it. If you think more discussion is needed, don't delay the discussion, because while the maintainer remembers what they were doing, is the best time to ask them about it. That golden rule we talk, maintainers being the only path. If unresolved feedback means patches are not accepted, you have to solve that. You have to get around the feedback, either by expressing why it shouldn't be done or by doing it. And yeah, you're looking for that positive way forward. You're looking for the way that suits everybody, the consensus path, not necessarily your own preferred coding style. So the good example. So here we've had, in this case, it's a casing fix. So add host 1x, DC, and HDMI to this device tree. And somebody's come back with the very, very simple uppercase DC and uppercase HDMI, meaning fix these and make them uppercase. We'll fix, and that means the next version of the patch will use the different thing. It would be a good idea perhaps to fix the subject line at the same time. But yeah, that's all you need to say. If you're planning to fix it, you just say we'll fix. If you do not act on previous comments, maintainers tend to get quite unhappy. This example is the best thing that could happen to you if you were ignoring feedback. So to repeat my further comments, comment it, do not ignore review comments. That's the kindest reply you get. If somebody's really, if you do it multiple times, or you're really starting to get on somebody's nerves, what you'll get back is just, there was outstanding feedback, and it will be your job to go and find it in your emailer. So yes, sometimes people will quote the previous example, but yes, if you have been particularly if you've done it multiple times, you'll just get back a message to say, please don't ignore the previous review comments, address them. Example here of that clarifying the idea that the person didn't understand the feedback first time round. So this was feedback about a device tree binding. So here we've got the specific value of the spy specifier shouldn't matter to this binding. What should matter is what it logically corresponds to. Given what is being quoted here, yeah, I don't know what that means either. So there was that request. It's quite clear. So there's some extra words. You can't just say, I don't understand, because it's quite useful to say, to give some hints about what you don't understand. So are you suggesting that I do this? Or in this binding, one needs to specify mode operation. It's for SATA. So that's both providing some additional information that maybe should go into the binding documentation. But it's not just saying I don't understand, it's providing some extra bits so that the maintainer can pick up on what it is that needs to be discussed. So that's a really good way of seeking clarification. This is an example of, I'm going to say, ineffective upstream advocacy. So this was it's quite a long time ago, I should like to add. This is a long time back for all parties involved, because we don't want to pick things that are a bit too recent as examples. And it was based at a point when the All-Winner platform wasn't using device tree. And the feedback had come back on the mailing list that this platform needs to adopt device tree. And the pushback is, please state that you don't want to accept the code for All-Winner as it is. And I hope it's obvious. I don't want to labour this too much, but that's ineffective advocacy. That is not going to persuade a maintainer that it is better to apply the code than to ignore it. And very, very clearly in this case, it is a way to encourage people to ignore you in the future. Okay, so once you've got the feedback, you should collect it up. You should keep track of it. You should create the action list of changes that you need to make, and you should keep a track of who asked for what. So after you have done that, after you see the comments, you make the changes that have been requested. You use the various Git rebase and things we'll talk about next week to update the patch series. You do a new Git format patch, you update to version 2, and you send it out. At that point, you should always provide a changelog summarizing the changes and showing the feedback that you addressed in this version. For most series, you put that in the cover letter. So it just says changes in V2 and then you list the changes. I like also to put in brackets the person who requested the change, because as a reviewer, you probably remember, certainly if it's sort of a couple of days ago, that you requested 4 changes in this thing, and you can go down the change log, find your name and say, oh, excellent, all my stuff has been addressed. And it's just more comfortable to understand what's going on with the change log. You must remember to increment the version number. So patch without a version number is implicitly version 1. So the next version will be version 2 and then version 3 and so on. And be absolutely prepared that version 2 might get additional comments, even on the stuff that hasn't changed. And you might well have to go around this a few more cycles. So we're going to look at some different types of sort of feedback comments that you might get. So the most common type of comment that will come up when you send something out for review is small requests for changes and fixes. And you should regard that as a good thing, because if somebody is asking for changes, often, not always, but often it means that there's no obvious problem with what you're trying to do. Most of what you've done is okay, and there's just some bits that need improving. That's the kind of rough hint you can see with these kind of changes and fixes. Things like fixing bugs in a broken error path, better APIs, KZalloc, for example, or devm KZalloc, improving the coding style, better ways to express something. And if you are willing to accept those changes, yeah, just saying, okay, thanks, ACK, and then a couple of days later, resubmit a new version. One thing about feedback is don't be too overeager. If somebody requests a change, you do need to give a couple of days for other reviewers to have a look as well. Maintainers don't actually like it when you get a new version of the patch set every day, because they can't figure out which one they should review. This kind of ego mention here, this is that other time to ego check. So the test is not necessarily whether you personally like the change or fix. The test you should probably apply is whether you can live with the change or the fix, whether you are comfortable with it, whether you think aligning the code here is better than aligning code there. Doesn't really matter, because it's much easier to make the change than to argue with the request. So it's a particular, but this is where your ego does get in the way. Mine certainly does. I want it to look like that. But you need to take a little bit, step back and think of what is the most pragmatic way to get my code delivered upstream. So the other thing that can happen, positive cheerleaders. Effectively, your code and ideas may get reviewed bys and ACK bys from people upstream who have a kind of strong reputation. That can be very helpful in convincing others that then go on. And it also encourages certain reviewers who are being maybe fussy and detail oriented that they don't need to argue with you, because they're not going to push too back against these people with high reputations. So any public support that you get is valuable. And finding people who are going to work with code, I'm always a little nervous of expressing like this. You get opportunities to meet maintainers and others at conferences and other places, and if you find yourself chatting to them, you are just socializing. Let's be clear, when you hang out in social situations at conferences, you are socializing with people. So it's not the case that you should be Machiavellian trying to steer and capture yourself a pet maintainer. That probably won't work anyway. But when you do have opportunities to meet people, they can be an excellent source of advice and if they are interested in what's going on, they may go and read it and they may contribute. So I personally would approach this as it's the sort of thing where you could ask for advice, why this, why that, can I do this better, is a better way to get involved with these things, both internally and externally. If you've got people who are very good at upstreaming in-house and who you respect, asking their advice is very helpful as well. The other, another type of excuse me, another type of comment that comes back is just the ACK. This is usually reflected as an act by or a reviewed by tag. These people basically saying that they believe that your work is good enough to go into the kernel. They get put into tags. We'll discuss exactly how tags work next week, but they're definitely signs of public support for your work that maintainers tend to take note of. So when you see act buys and review buys come in, they're a good thing. Again, you should keep track of them, because if you send in a V2, you're expected to collect the tags and replicate them. But we'll cover exactly what they mean next week. So some difficulties, and we do talk about the difficulties. My experience of upstreaming, other than checking my own ego, is that it's a very positive experience. So I don't want to oversell the difficulties, but they do potentially exist. There's kind of a couple of different ways to come up with these things. So some people might want to mark your patches with some idea of theirs. They have some hobby horse that they like and they want to change patches. So if you get particularly weird changes, it's definitely worth looking back through the review list for that person's name, see if they make that suggestion frequently and if others copy it or not. And if people argue back with them, you might wait a day or two to see if somebody else argues back, and if not, cite these other references. There are possibilities of people with hidden agendas. They want to do some work similar and want to slow down your work. That's very, very rare, because most people care about the quality of the Linux kernel, and slowing it down is generally not its thing. So bike shedding is probably the most common form of difficult activity. Bike shedding is named after the idea that lots and lots of people, no matter whether they've got any experience in making bike sheds or not, have an opinion about what color a bike shed should be. It's very easy to say, green is a great color, let's paint the bike shed green. So bike shedding is describing this process of derailing a discussion, probably unintentionally, by focusing on unrelated tiny cosmetic details. And a limited amount of bike shedding is fine. You just accept and do what's been asked. If only because calling out bike shedding is quite it can be difficult to call it out, but certainly be aware that if discussion doesn't appear to really be focused about the patch, it's about whether you call something this or call something that, you can just let the thing blow out. Or you can come back and say, well, yes, I'm going to call it this unless somebody has a strong technical reason to try something else. That's the best way to do it. And of course, the best way to learn about this stuff is to watch other people handling it on a mailing list, which we'll come to at the end of today. I've put trolling and flaming at the bottom, well separated, because it's very uncommon these days. It can come up. But trolling and flaming, the mailing list is a professional space. So most people interact on it in a professional way, and trolling and flaming doesn't fit into that manner. And it's a public mailing list, so it is observed. So yeah, don't respond to trolls and flames in kind. Take a keyboard break. If there is no request for changing it, probably ignore it. If there is a request for change buried in there, decide whether or not you want to accept the change or not, and handle it as though there was no flame or troll in it. Basically, handle the technical content as you would otherwise, and otherwise don't do things. Okay, so there is a question come in while we're talking about the resends, which is that, do we have to rebase our patch on the latest tip every time we send a new patch for review comments? I don't personally. So the requirements will vary by subsystem. So my default is to pick the most recent mainline tree that's been released. And then I will lock to it for the rest of the thing. So for example, I might send a patch based on 6.2 RC3. And I just wouldn't rebase. I'd leave it on RC3 unless I knew there were some changes coming further through. If the patch went through discussion and there'd been a new kernel release, I would rebase on a newer RC. So I tend to follow a release candidate to RC1, for example. I would use that as the baseline. When there's a new minor number change, so 6.2 to 6.3, I would then tend to rebase, otherwise I wouldn't. That is not the same for all subsystems. So that's a good default, basically, to use a relatively recent release candidate and then to lock onto it. And the reason for that ultimately is because during the release candidate process, you should only be getting bug fixes. It's unlikely there'll be any major API changes or any major things that mean your patch no longer applies. And maintainers are usually quite happy with this. What you will occasionally get back is this patch no longer applies, please rebase it, and they'll ask you to rebase on tip. Or they'll ask you to rebase on their own next tree. So if you work with people like Greg Hartman, if a patch doesn't apply, he will ask you to rebase it on maybe TTY next, which is his own tree that contributes to next. So that's the most complete answer I can give. If you see that particular subsystems routinely do rebase, then it might well be a sign that subsystem has kind of different norms. But that's my personal approach, is that I only make a significant rebase as we jump through minor number changes. Moving back to that comment about difficulties. Like I say, I'm very nervous of talking about difficulties, not because they don't happen, because they're very, very rare. And I want to instill confidence in people who are going out to upstream. So this strange graphic here, this is a grey squirrel. And in my country, the UK, the grey squirrel is non-native. It's an invasive pest. It's also really, really cute. And it's not even hostile to our native squirrel population, which are called red squirrels. It doesn't actively hurt them. It's not excessively territorial, but it can eat acorns and it carries disease. In other words, it's responsible for the diminishing red squirrel population, but it has not got any particular malice. It is not doing any bad behavior. And I want you to think about a lot of these difficulties in the same way. When you see feedback on the mailing list, don't assume that this slide applies every time, because it can be poor communication. It can be good communication that you've misunderstood. Certainly trying to assume a hidden agenda, for most people, there won't be a hidden agenda. So these difficulties do exist, but they are very, very rare, and you shouldn't focus on them in your conversations. If you develop a feeling over time that somebody might be demonstrating some of these behaviors, that's fine. But certainly single emails should be, you should not just assume this is a difficult case. Treat it as normal unless there's a lot of evidence that it is a difficult case. Because like I say, there's nothing wrong with this grey squirrel. It's a very lovely animal that is not even fighting. So don't assume bad intent as a default. It is something you should be aware of in the back of your mind, but it's not something you think about all the time. Okay, and the final type of comment I want to talk about is called a knack. It's the opposite of an ack. It is an explicit statement that this patch should not be applied. It's not documented heavily in the process because it's almost develops implicitly. When we have an ack, you can have a knack, not acknowledge. In it's a shock if you get a NAC. I've received one, and I worked through it, and we fixed it up, and we sent it on. But yes, it's a visceral thing. It's saying this patch must not be applied. It's usually saying there's a fundamental problem with it that needs to be addressed before you consider applying it. It's somebody saying this patch would be actively harmful to the kernel if it was applied, which is why it gives that kind of visceral reaction. You do expect some information surrounding the NAC, so you should get some reasoning. And if it's for a reason that you can change or fix, you can still recover, modify, change things. If there is something fundamental about your design and is being NAC'd because of that, you are going to have to start again. It may be a patch that represents a significant amount of work. Hopefully not, because you can try and avoid NACs by things like RFCs earlier in the process. But yeah, if you get NACs that you can't avoid, you are going to have to go back, you're going to have to start again, and you're going to have to try a different design. So usually you sit in this top thing. There are things you can change. The NAC that I received was one that I was able to sidestep without redeploying everything. But it's definitely a sign you need to have a rethink. You need to think about what's going on, and you need to decide what's going on. It's also a good time, if you don't really understand what's going on, it's a very good time to reach out to a mentor, either internally or finding someone to help you. Okay, and then finally, just understanding the process of the progress of patches. When you're reaching up as far as sending a patch, all your normal project management work will be intuitively understood. You know how to quantify how long it's going to take you to read about the subsystem and learn things. And so you'll get that kind of intuitive understanding of your progress. But once the patch is on the mailing list, if your project manager or manager asks you when is it going to be applied, you do not know, because ultimately you're just waiting for feedback. So companies do a lot of upstreaming actually change their project management approaches so they can put work into a state where it is waiting for somebody else's feedback. It's not quite blocked, because you still want to wake up every now and then and poke or resend, but it's not in your hands as to what happens. So the amount of remaining work after you've sent it to the mailing list is potentially unknown. You don't know how many fixes you're going to be asked to apply, whether you're going to have to redesign, whatever else. So yeah, people who upstream a lot do develop project management processes to help with this, but it does take time. And you can also follow and assess. When you've had a maintainer review that's asked for a small number of changes and you've made them, there's a good chance it is going to be accepted, and you do get a feeling for that. Once the patch is accepted by the maintainer, things get fairly predictable again, because it's now related to the merge window, which we'll talk about next week. And so the point at which that patch will appear in the next kernel does start to become well known, assuming no problems are found with it during testing. But it does give you once the patch has been accepted by the maintainer, now the roadmap to landing in the Linus tree is well understood. So the kind of final things of not to forget. So while we're dealing with review, remembering that upstreaming is a social activity. And people that maintainers know and have had good experiences with get a little bit more slack and become more effective at upstreaming because of it. It doesn't hurt for people to recognize your name and to have met you and to remember you. And one of the simplest ways to get known is you can actually just quietly get on with doing a good job if you're working in the same subsystem, so the same maintainer sees you over time. Another thing that maintainers quite often appreciate is contributing to code review. So once you've gained kind of enough experience of the code review culture on mailing lists, you can participate in review as well. Maintainers do tend to spot that. It also implies that you're on the mailing list and just taking part in the activity. You can't always do that. If you're jumping from driver to driver to driver to driver, you won't have that time to look after things. And then finally, upstreaming, as I've mentioned, all the difficulties and the silly squirrels and everything else, upstreaming remains, for me, a very positive experience. I've learned a lot. I've advanced my own understanding of what maintainable actually means a lot over the last few years. So yeah, it's a good experience, but they still don't care about your schedule. So final couple of bits, maintenance. After your code has been accepted, it is now being maintained by somebody else. But if you are a SOC vendor, it is still probably the case that nobody cares that the driver works more than you do. A lot of maintainers actually can't run. You know, I'm a maintainer for hardware where I have less than a tenth of all the available hardware. So I can't physically test when I accept code, nor should I. So you are the person most, or the company, the entity most motivated to maintain the testing of the code to make sure that it continues to work. So getting involved in future testing, you know, when a new kernel comes out, runs some tests from previous upstreaming can be a very valuable way to make sure that the system still works. Sending in bug reports, again, does quietly build your reputation. The other thing that's likely to happen is your name will pop up when you run get maintainers on a particular file. So you will be asked to review other people's contributions to files that you have created. That's a really good start to get involved in code review. Maintainers will really like it. If somebody sends a change to your driver and you look at it and you can't see a problem and you send a reviewed by, that's the sort of thing that does build your reputation as somebody who is collaborative and helpful. So yeah, that's sort of thing you can do after the fact. So to close out for today, we're actually going to look through a specific example. So the summary of what we've talked about so far is that you should ask questions. You know, that social activity works two ways. I've talked about it as a social influencing process, like it's standalone, but email is designed to send messages from people to each other. So if you need help or advice, you can send out questions on the mailing list, just as you can for any other communication medium. I particularly like to use RFC as a good way to ask the question for a couple of reasons. One is that in the community around the kernel, code definitely does talk. The other is that anybody who subscribes to big mailing lists like the kernel mailing list filter it tremendously heavily. And it's quite possible that one of the subscribers is the person who can provide you the best advice. Maintainers are not going to be the only people who respond to RFCs. Other people involved in the subject. I've just advised you about how to get involved in the review processes. Other people like that will be around on the mailing list and can help and advise if their filters show them your question. And RFCs, which are basically patches with a description describing what you're undecided about, will be picked up by the filter. So I tend to filter by file name. A lot of my filters are saying that if you are touching this directory structure within the kernel, I'd like to know about it. And so because of those filters, if you send it as a patch, those filters will trigger and it will go in front of useful eyeballs who are interested in that particular area. If you just send in raw questions without patch associated, you are less likely to sneak past those filters. So that's why I like to do RFC questions. I have pointed you at a couple of resources in documentation. It's always worth reading as much of the documentation as is relevant to you. You should use email in the way Upstream expects. Now, I've talked about using Git send email, and as an aside, I also mentioned discussing with other Linux developers in your corporation about how to be able to send a plain text email from your system. It is in the documentation as well. There's a piece called documentation email clients, which help you learn about the right way to configure an emailer. But the best and most robust way to do it is to ask in-house. We did have that aside about it's got your name and your employer's name on it. Make sure that counts for something. During the feedback stage, every comment you get back, take seriously. and address it quickly, but not too quickly. That idea that you want to leave a couple of days for feedback, you don't just spin the patch every time somebody sends you a message. And that final detail that a maintainer has to apply your patch. So you have to be able to carry the maintainers with you when you want to make a change. Okay, so our specific example now is going to be upstreaming a driver. It's a fairly simple driver. It's a watchdog driver. So our first job when we're thinking about this is after we've researched how the watchdog system is set up. So we've had a look at some drivers from the watchdog system. We're confident that our C code is approximately right. So our next step is to logically split up that work. And so the main split that we're going to perform is between different maintainers. So in terms of telling the story, if you have code that is impacting different maintainers, ideally you send a patch which contains changes that are most relevant to a specific maintainer. And some different examples. One, you're doing driver updating. Firstly, you might have to write a device tree binding, which is description of what the device tree properties mean. And that will be maintained by the device tree team. And you would want to copy it to the watchdog maintainers. So Wim van Sibroek and others is the watchdog team. And then we have the device tree team as well. So you would send it to both of them, but it's separated from all the other activity. So the device tree binding, which is the documentation of what device tree properties mean, is a completely separate patch to any other. And it's just going to change the documentation in documentation device tree bindings. If your driver was to require any watchdog framework changes, so if you had to add a new feature to the subsystem, I mean, this is pretty fanciful for a watchdog, which is a very simple peripheral. But if you had created an innovative new watchdog that required a new subsystem feature, you would bring that in next because your driver would require it, and therefore you need to make the changes to the watchdog framework before you add the driver. You would also add it separately so that the watchdog team could review the framework changes to decide if they like it without having to think about the complexity of the driver itself. Next patch to land would be the driver in build plumbing itself. So this is the main driver, and by build plumbing I mean make file and kconfig. That would go to the watchdog maintainers as well. If you wanted to change the def config, so if this new driver is something you wanted to see turned on by default, often you don't in ARM64 systems, but if there is an applicable def config update that you think should be made, it would either go to the architecture maintainer or the ARM SOC team to update all the DTS files in the, sorry, not DTS files, to update all the config files in Arch, name of Arch / configs. So in the case of ARM64, I believe that is managed by the main architecture team. And in the case of ARM, it's managed by the ARM SOC team because ARM has a historically large number of def configs. And then finally, if you need to enable things in the device tree themselves, you would have patches at the end of the patch set to enable it in the device tree. So that's what I mean in terms of a clean setup for a new driver. If you're creating a new driver, this is a pattern. And in most cases, you only end up with the device tree binding, the driver, and the DTS additions. The watchdog framework changes are unlikely. You don't often have to add those. Likewise, def config changes are not usually needed for a small driver from an obscure, well, I say obscure, an embedded system. It's not something that necessarily wants to be enabled on all platforms. So that's our nice clean example split. And that's how it would emerge in this particular example. So the actual patch we're going to focus on is, sorry, the actual patch set we're going to focus on is super simple because it only contains 2 patches. It's got the base watchdog driver and it's got the ARM watchdog configuration. And the reason for that is this driver did not require device tree to configure itself. for various reasons. If it had had a device tree binding, it would have been a patch that would look like this instead. So this is the adding the device tree binding, enabling the watchdog driver, adding it to the def config, and adding it to the device tree. But this particular patch didn't need the device tree aspects, and it does allow us to have a much simpler set of patches for us to study. So to post the driver, what we want patch 0, 1, and 2, cover letter, which is copying the same name from this one. It doesn't have to be the same subject as the main patch, but since this patch is dominated by adding a watchdog driver, it's just the same name that's been used for the subject. So to get that, we run git format patch, we ask for the cover letter, we ask it to be stored in this directory. We do the 2 and the CCs, which we picked up from get maintainer. And we've said we would like to look at these patches. So there's a number of different ways you can express which patches you want. This is explicit. This is basically saying that I know that patch 1 is applied to 4.3 RC1, and I'm going to explicitly provide the SHA1 of the final one, and that will select me those 2 items from Git history. I actually personally myself put in -2. So you can say I would like the top 2 patches by saying -2, and that will pick the first 2 patches from your history and share them. And if we look in that directory, we can see that it's generated a cover letter and the patches to go out. At this point, I would eyeball them to make sure that they look what I expect. And I would edit the cover letter. So by default, the cover letter will have a couple of placeholders in here and here for you to fill out. So it will have been pre-filled with all this aspect. So this is called diffstat, and it allows it. I'm just going to change the wrapping because it's hard to see. It's now technically wrong because we've got the wrong number of pluses, but it's easier to read. So the diffstat effectively records new lines. So here we can see we've got some new lines in the config file, some new lines in kconfig and make file, but the bulk of the change is in the this new watchdog driver. And diffstats are looked at by maintainers to kind of get a shape of the patch set. So that's automatically generated for you by the format patch, along with this summary which says who wrote what patches. But this section in here will be left blank for you to fill in, as will the title. So you edit the cover letter, you add the components that you want, and then the patch set is probably ready to go. The main patch, the one with the watchdog driver in it, has a message. New drivers tend to have relatively simple commit messages. This commit adds support for the watchdog timer used by the Broadcom family, this particular Broadcom family of socks. Sometimes you might add a little bit of information in here about the nature of the watchdog, maybe some key information about its data flow to help a reviewer. But anything you put in here is basically guidance to help reviewers make a good job. It's then been signed off by Marcus, and at the point it's being first shared, it's also got a reviewed by. And what this means is that there was an internal review done before it hit the mailing list. And it was being done essentially because we had a more senior developer who was reviewing the work ahead of time, providing feedback and mentorship. And the fact that that had taken place behind the scenes was being recorded by sending out a reviewed by. So Marcus would have had to have Matt permission to add this, and then they would have shared that internally. In most companies, internal review process is done by emulating external review process. That's certainly how I do it. So if somebody asks for my help in getting started upstreaming, I offer to say, do the get send email, but send it all to me, not to the mailing list. I then do an internal review, much like it was an external review. And depending on the circumstances, I might provide them a reviewed by or not. But that's what's happened this case behind the scenes. Somebody's provided some contribution. And that's not required, But if you're going to have large internal debates about the best design decision, it can happen on the mailing list. It sometimes does, but it can equally be quite a good idea to get some of that done ahead of time. We get comments. So this is, oh, I should have scrubbed the email address, but this is the feedback that came through saying basically this is the wrong choice of return value E again. E again is actually quite special because it causes the, has some fairly specific semantics around signals. So E again is being fed back as the wrong error value, and it would have some nasty effects on the C library if you were to keep it. So they suggest a better value would be IO error. So Mark has just said, yep, I'll make that change, no problem. And new versions come out. So this is version 2. This is our new cover letter. And it says changes since version 1. I don't like changes since version 1 because I get the math muddled. I prefer changes in version 2. Just because this always feels like an out by one error and it's hard to get things right. But they've then listed all the changes that they've made. Module name, this, that. I've switched away from the EIO somewhere in here, I hope. It's listing all the changes that have been made so that other people can check that their review feedback has been acted upon. And at the end of this process, you'll notice that the subject line has now jumped to version 5. Hi, Marcus. I've applied the patches, but without the debug part because I still have some questions about it. This was quite generous by the maintainer. I presume there'd been some discussion back and forth and Marcus hadn't been given really clear guidance. So, like I said, this is quite generous maintenance. Some maintainers, probably including myself, would have said, please drop the debug part, I'm not happy with it, and send me another patch. But I suspect there may have been some discussion between version 2 and version 5 that has led WIM to take this particular approach. But that's acceptance, and that's the sign that is now being put into effectively the next tree for Watchdog. Usually that means the code would now start to appear in Linux Next, so you can test it in an integration testing setting, and that we know the process of delivering it in total. So we're now at essentially the end of today. I'm going to talk briefly about the lab sessions in a moment. But this is that slide from the beginning. What is upstreaming? And this time I have bolded the process of technical and social influencing. You've noticed as I've been talking, I've back referenced this description at the bottom over and over and over again, because it is the mindset that makes upstreaming most productive, in my opinion. So I hope the difference between these two definitions is now really quite stark, that there is something missing from the top definition. And with that, I will come back to thank yous. But so lab sessions. For upstreaming, traditional lab sessions don't really make sense. So I can't give you like an exercise to go off and do some upstreaming. But there are things and actions you definitely can and should take. So the various descriptions of process. So I've given you an overview of the process today. You should read the documentation and look for the similarities and nuances that I haven't been able to fit in. And I also suggest having a look at this series, which is it's getting quite old now. It's a Greg Hartman series. It's called How to Piss Off a Kernel Maintainer. And it was basically Greg documenting behaviors that he had seen as a maintainer that, let's just say, could be called suboptimal. Things that were not presented to him in a way that made his life as a maintainer easier. So that's some interesting reading material. I'm also going to put this video in front of you, and I want you to be very reflective about this video. So this was called I Don't Want Your Code. Again, it was from Greg, and it was delivered at Alnaro Connect in 2013. Now, this video is quite old, and the recording quality reflects it, and it does not make Linaro look good. To which I can only really say that it is 9 years old, and it provoked very significant changes within multiple companies, including Linaro. And we hope, at least, that the challenges that were being described by Greg no longer apply. There is also a slight risk that it will dent your confidence. So I don't want you to consider this. This is not a dire warning. It's basically a don't make silly mistakes if you can help it. Make sure that you put in personal habits so that you are testing, so that you are building, so that when you send code to the mailing list for review, it doesn't contain obvious quality defects. Because this talk describes how some maintainers will react if that's what you do. And it's quite an entertaining talk, because my feeling is that Greg knows that he's holding people to a very high standard, but the reason is, why should he not? Why should he not expect high standards for a project as important as Linux? The other really important thing I would recommend you get involved in straight away is to do some learning by watching. Your goal is to watch upstreaming happening. You can do this. I mean, absolutely, there are mailing lists happening all the time where upstreaming is happening now. And you can watch it and you can think about it and you can reflect upon who is doing a good job and who is doing a bad job. And while you can't go out and upstream until you've got something to upstream, you can definitely join mailing lists and observe upstreaming happening and try to figure out who's doing a good and bad job. So yeah, go and join a mailing list. Join one for a subsystem that interests you, either because you've been asked to work on it or because you understand the hardware. So, you know, if you're an I2C expert, if you've got MMC or SD card experience, go and find a subsystem that reflects hardware that you know something about. And just subscribe to it for a week and see if anything interesting crosses your desk. Look at the patches that come through, look at the replies that come through to the patches, and try and figure out who is doing good and bad job as things go through. You can also learn a lot by looking at things like Linux Weekly News, where some of these mailing list discussions get discussed. But yeah, so subscribe to the mailing list just for this week. You don't have to stay subscribed to it, but try to look at upstreaming happening and seeing what you can find out. This link here is a description of the Minare. So Minare is sometimes viewed, I don't know if it's right or wrong, as a form of Japanese approach to learning based on watching and reflecting. So I suspect I have a very bad Western approximation of what that really means. But yeah, there's a link to what Minare is when we look there. And that's what I recommend for the next week to help you develop more about upstreaming. So I'm just going to switch to a further question. So for the watchdog example, but I understand the need of sending separate patches for different areas, but individual patches laying in different areas may also depend on each other. In that case, do we follow up these patches one after the other once the previous ones are accepted, or can we do it in parallel? So let's go back to our canonical list, this one here. So there's a number of different ways. To some extent, you're presenting patches in this sensible order, and it is the maintainer's job to figure out how to work together. So what will often happen in these cases is maintainers may send an act by. So that act by tag that I've discussed is not just an approval. It's also a permission for another maintainer to apply the patch on your behalf. So I think it's quite common in the DT subsystem. It's been a while since I've done a full driver of my own, but my recollection of the DT subsystem is that when you submit stuff like this, it will be very common for the DT binder to get an act by from or reviewed by from the device tree maintainers, and it actually gets applied by the watchdog maintainers. The others perhaps less so, but ultimately that negotiation happens between the maintainers. You can ask, one of the common things you might choose to ask is who should apply this? Is a good question to stimulate discussion as you go through, but it's that social aspect. You can discuss that with maintainers and they will tend to figure out how to land these things. One clarification is when we talked about the 2 patches, it wasn't that we dropped the DT binding, it's that this particular example it's running for hardware that doesn't have device tree. So this is not I dropped device tree. It's that we adopted a simpler example for the purpose of this demonstration that actually didn't need device tree to activate. So it's not that we dropped the first bit and the last patch, it's that the example didn't contain them, but we wanted to express that if we were using DT bindings that they would. So that's, I think, the most complete answer is that you do quote the right thing. And how individual maintainers work together tends to be discussion between the maintainers. I mean, the thing that is true about this is that the DT binding can be accepted, regardless of anything else. That the nature of DT bindings is they're not linked to drivers. They're supposed to describe the hardware. And because they describe the hardware, they will be correct regardless of how the driver is implemented. So they can be applied locally, but it would be more common, I think, to have act by coordination and for this all to be applied by a single maintainer. But the only technique that really is important when you are a contributor is that if it is unclear that the patch is going to be taken, or you're getting towards the start of a merge window and the patch hasn't been accepted by anybody, if there's no negative feedback, you might ask, who's going to apply this, that kind of thing. And look for examples. One of the reasons we do the learning by watching is you will see this happening in the real world. You can find a driver that has been recently. You can even look in the mailing list archives. You should be able to find a version of this pattern, probably without the configuration patch, but you'll certainly see this 3-driver pattern repeatedly on the mailing list. So when you look at that mailing list history, you can see the interactions taking place. So that's the best way, I think, to educate yourself in exactly how this happens in the real world, is just to go and find in the mailing list history these kind of 3 drivers coming in, not necessarily the watchdog ones. Every ARM driver, or almost every ARM driver, will be an ARM binding, a driver, and a DTS change. So look at those and see how they land. So I've come up to time. If there are any other questions, I am happy to take them. Oh, this will be in the Q&A. Ah, that's one we've already had, okay. So there is actually a question in the QA about who to put in the 2 and the CC. We will, I think, cover more on this next week. So the philosophy of 2 and CC is that 2 is the people you expect action from, and CC is the people you think might be interested. So maintainers are almost always in the 2, if they are the maintainer of that subsystem. So for example, when you send that, in fact, we have it up here. The device tree bindings would be sent to the device tree team, device tree maintainers, and the watchdog maintainers. The reviewers from, if there are any DT reviewers or any watchdog reviewers, you would put them on CC. And if you picked out anybody from the commit signer list when you did a get maintainers, you would add them to CC as well. So 2 is the people you want action from, i.e. please apply my patch. CC is for people you want to keep informed about the change and who might choose to review. And for some people, the difference doesn't matter, and other maintainers actively filter their mail so that 2 is preferenced above CC. So I've had this in the past. I don't anymore, but at one point I used to colorize 2 differently to CC so that I could go through my mail and pick out the things where people needed actions from me. So that's the main difference in 2 and CC. It's who's going to take the action, and it does help. Getting 2 and CC right does make it more likely that some maintainers will apply your patches. It does depend how they handle their own email, but it does impact things. Okay, so like I say, I still have a minute or two if anybody wants to put in any final questions, but I am at this point done until next week. And I have the reminder about support@linara.org if you have a slide number and want to pass on any kind of question. Excellent. Well, thank you very much for spending time with me. Next week, we're going to focus much more on tools and techniques rather than the mechanical kind of this is how you create a patch and get it out the door. So that's what we should talk about next week.